Using graphs to solve systems of equations. A system of equations is a set of two or more equations containing two or more variables. On the graph of a system of two equations, the solution is a set of points where the graphs intersect. A point is a solution to a system of equations if the x and y values of the point make both equations true. Example 1. Tell whether the ordered pair is a solution to the system of equations. So remember, ordered pairs are x comma y. So for x, I'm going to plug in 2. For y, I'm going to plug in 1. So this was where the x was, and this was where the y was. Negative 3x plus 2y equals negative 4. So where the x was, I'm going to replace the x with a 2. Where the y was, I'm going to replace it with a 1. So if this is a solution, then it should equal negative 4. So negative 3 times 2 is negative 6. 2 times 1 is 2. So negative 6 plus 2 is negative 4. So it works. Negative 4 is equal to negative 4. So it works for this one. Now we have to check and see if it works for this equation. So I have y equals negative x plus 3. So where the x was, I'm replacing it with 2. Where the y was, I'm replacing it with 1. So if this is true, it should equal 1. So negative 2 plus 3 is 1. So both sides equal each other is true. So yes, it is a solution. Okay, graphs. We are going to graph these. Remember, the equation needs to be in y equals mx plus b, where m, that's your slope, that's how you move, and b, that's your y-intercept, that's where you begin. And you always begin on the y-axis. So for this one, your m is 1/2, and your b is negative 2. So you're going to begin at negative 2 on the y-axis. And your rise over run is up 1, right 2. Up 1, right 2. Make sure you go all the way across, all the way left and all the way right. Okay, for the second equation, your m is negative 1 over 1. Remember, if there's no number in front of x, it's 1. And your b is 4. So you're going to begin at 4 on the y-axis. Put a point at 4, and your rise over run is negative 1 over 1. Since it's negative, you're going to go down 1, right 1. So you see where they intersect. That is the solution. So right there, that is the solution. So we have to find that ordered pair. 4, 0 is a solution. Okay, for this one, they are not in slope-intercept form, so we're going to solve for y. So remember how to do this. We have to distribute 2/3 times negative 3 will be negative 2. Bring down y plus 1, minus 1 on both sides. So we get y equals 2/3 x minus 3. So my m is 2/3 and my b is -3. So I'm going to begin at -3 on the y-axis. And I'm going to go up 2, right 3, up 2, right 3. Okay, with the second equation, we're going to solve for y. So I'm going to move the x, subtract the x on each side. So I have y equals, remember I cannot combine these, I just copy them down. So my m is -1/1 and my b is 7. So I'm going to begin at 7 on the y-axis. Okay, so my slope is -1/1. So I'm going to go down 1, right 1. Okay, I found where they intersect. That's the solution. The solution is 6, 1. Okay, so there are 3 possibilities. If the lines intersect, they have one solution. So for example, these 2 lines intersect at -2, 1. So if they intersect, you find the point of intersection. That's the answer. If they don't intersect, they have no solution. So the symbol for no solution is a 0 with a slash through it. So if it's no solution, the lines will be parallel. Remember, parallel lines have the same slope. So if 2 lines have the same slope, but a different y-intercept, then they will be parallel and they will not intersect. Therefore, they will have no solution. And if you have 2 lines that are exactly the same equation, then the answer is infinitely many solutions. The symbol for many solutions is an infinity sign.